Yeah, because if you think about it, right, we are a delivery company that uses drones and uses operational excellence and software to automate the use of those drones. We do not need to invent wheels that already exist, right? So if you're a company that is smart about its strategy and its product, you know that you need to go fast, and the hard part is being regulated. It isn't the underlying tech, really. I mean, a lot of that work is done. So GPSs, there's all sorts of anti-spoofing stuff. There's, all sorts of tech in our aircraft that we didn't build. But the most important part is the bit of tech that flies the aircraft, right? And in our case, we looked around and we said, okay, do we need to get a load of IMUs and accelerometers and gyros and crap and put them all together on top of our existing already complex PCB? Or do we just look around and say, is there anyone already doing this? And there's a bunch of companies doing it, but we kind of concluded that, look, what the hobby industry was using at the time, the Cube, was actually a very popular product for a good reason. It was approachable. It was married to open systems like autopilots. It had a community of people that were used to it and supported it. It obviously wasn't going to go away quickly, because that's important. Right? There's no point buying a component that's just going to disappear later on. So we looked around, we saw the Cube, and it wasn't by any means like, it definitely didn't shout type certified this would go in your Airbus or your 737 anytime soon, but it was plenty good enough with very, very strong support from the open source community, and we're an open source shop. So I liked that. And then I said, okay, well, look, we don't know enough about it yet to say, okay, I'm going to fly my children powered by this autopilot yet. But we started to evaluate it. We started to fly it, and we never had a problem. And we were never given a reason to say, okay, now it's time to grow up and build our own. And we still don't have that reason. And every one of our aircraft has three CubePilot, three orange cubes on it. And we have three because it's prudent to say, irrespective of how good the cube is, it's prudent to say, look, ultimately it'll fail, right? Everything fails. So we have three on our PCB, and then we have hardware voting system between the three, and they all think they're flying the aircraft. Only one of them is. And then we have voting in hardware, and when we switch automatically between the cubes, and all of that was a breeze for us to implement, and then we didn't have to reinvent the cube. So, and our aircraft's a big bus, right? It's like the full 20 kilos minus the cargo. So we have room for three autopilots and not one. So we have a little bit of ability to carry a bit extra weight, so it's no big deal. And we are not selling aircraft, so we're not focused on ultimately the cost of the aircraft. We're focused on the safety of the aircraft. And we have no reason to think that the Cube isn't the safest autopilot in the world. And then when we triple them up and we make them, redundant, then it's golden. And I think Philip and his team have done a great job. They've advanced it. We started off on a black Cube, which did not have enough processing power for what we were doing in certain circumstances. And then the Cube Orange has buckets of processing power on it. So, like, I don't see us moving away from that for any time soon. That's for sure.
And so those three are talking. They're just handling the flying, and then you've got another computer down the back that says, right, well, this is where we're going. This is the delivery we're doing. Now hurry up, get us there. And
We've
all it
three.
does,
We've
you've
three
got
computers talking to three cubes, and the three computers are on an Ethernet network, and they all measure the telemetry across all three. And then they pull a hardware pin that says healthy. Each one of them decides if its directly married flight computer is healthy based on the other two. And then the hardware switches between the three based on those healthy votes. And it's very, very rare. I mean, I'm not sure. We've had one cube fail on us, but that's because we were really abusing the thing on the bench in our test system. So, like, I wouldn't really count that. But
fair enough.
we've never had a failure of a cube in a production system. But we've tested the shit out of it. And if you do, like, if you put a little explosive charge onto one of our cubes and you blew it up midair, you wouldn't see the aircraft even wobble. So the switching across them is instantaneous because they all have state. They all think they're flying the aircraft. and they are. It's just that their outputs aren't connected to the ESCs. Only one of them is.
And do you have multiple pitos and things like that? Multiple GPS? Is it all
Yeah,
mapped in each one?
multiple GPS. Yeah, multiple GPS. We have two GPS units and four antennas. We have two LTE modems for comms. We have actually the only thing that's not redundant are so we have a pyro parachute,
Mm.
and that's got its own flight computer, and that's got authority over the whole aircraft, and that's got redundant IMU, but not redundant processor. But it's kind of that's parachutes for you, right? They're kind of line of
So
last
that's
defense.
your fourth system watching the flight then, and that one
Yes.
goes, oh, hang on, I don't trust any of this. Boom, pop the parachute.
Yeah. Shut the power. Wait half a second or so, and fire the parachute.
Yeah,
Yeah.
fire the parachute. I think you've used that once in anger, haven't you? If I'm right, I don't mean to be trapping you here,
It's
but yeah.
no, we did. Yeah. Dumb, an unauthorized maintenance issue on a bolt on a prop, i.e., tightening of a bolt by an unqualified person, over tightened, broke the bolt, blade came off, vibrations go up, parachute fires. So fine within our design, but not a happy incident for us. A safe one, but not a happy one. And that was in the old days. We used to have a single retaining bolt for the blades and the motors. We now have redundant. Um, it's a kind of an interesting. It's our own design. It's our own motor hub design. So it's redundant now. So you can lose your bolts all day long and still keep the blade on. But that's part of
Mm.
the industry's always have that. That's just part of the growth part, and that's what's another thing that's hard about this industry is you can't just go from 0 to 100 miles an hour. It's just the regulator's not going to let you, and they shouldn't let you because no matter how good your engineering is, you're always going to miss something. So the only thing that makes you and should make you feel safe is hours on the clock, flights on the clock,
Yeah, yeah,
and
yeah,
that's a
yeah.
learning experience for us. But what came out of that as well is, and this is important, having a safety management system, an emergency response system, all of these different components that kick in when something does go wrong, and that you're able to analyze it backwards and understand exactly what went wrong and then design that issue out. That's all part of running a safety organization. So it all worked according to what's written on the tin. So not a bad outcome, but it happened, and that's always going to happen. And if you look at our design, and we have a redundant battery as well, by the way. So if our main battery overheats or just stops putting out power for whatever reason, we have 60 seconds of controlled flight in a secondary battery that's protected with a diode. So we've 60 seconds to get to the ground, all the avionics powered, and we've computer vision that finds a safe spot on the ground to put the
I was
aircraft
just going to
down.
ask you that. So is that doing
Yeah,
old slope, shape, size, slope, surface, and all that sort of
yeah,
thing on the
that's
fly?
sure.
Is it? So continually as you're flying, you've got a computer looking, divert.
Yeah, correct.
Yeah,
We used to have a system of rally points where,
yeah,
like we
yeah.
in Balbriggan, it was like all these rally points spread out. Even flat roofs, anywhere is a good rally point, just safe. And turns out that's dumb because if you need to get to the ground quickly, you're not going to get to a rally point, right? So there's no
Mm,
point
mm.
having rally points really. So we just have a dynamic system. You've got we probably have 90 seconds, but we say you've got 60 seconds, get it to the ground. We can't go up, we can go sideways, and we're always going down as that clock starts ticking. So we've got 60 seconds of lateral movement to get to the ground. Now because we're flying at 70 meters, we already have a reasonable view of where to go based on that, but we wait to get to about 30 meters before we decide, and it works great. And all you're looking for is, like, we're flying over, the road goes through Dublin. It's the ring road, it's called the M50. It's like your A25. It's a big, big motorway. You do not want to be landing in the middle of that if your battery fails. So, and that's what we've designed that for. It's to land somewhere, no people, flat surface. That's it, and it works great.
What's the lowest altitude? I'm going off topic as ever. That you can trigger the parachute then. So let's say you've moved off to one side. Whoa, no! I'm
14,
now down to 10 seconds of 15.
14 meters.
14. So
Meters,
you
yeah.
could move it laterally and then trigger the parachute if you needed to just
Yeah,
cushion the blow.
yeah. We could, and like different jurisdictions will want us to do that differently. Like that's one area where the regulator has a view on what they would like to happen.
Hmm.
In in the EU, not sure where it currently is, but certainly up to now, it's been preferences on just firing the chute. So if you lose your containment, if you like, we've got 3 rings. So if we lose the containment within our 90 seconds, that's one breach. And then if you continually breach containment, then we have the outcome, at least in Ireland, and I think most of the EU, is just fire the chute, don't even try to land.
Yeah.
Um, so it just depends, and I think so. You need to kind of that's a conversation to have with whoever is setting the rules down. I love the idea of landing in situ because the tech is very reliable. Um, it's a good outcome to land on the ground, in a controlled way. A
Yeah.
parachute is not a controlled landing, but
Well, it's
we
just
can.
the situation. And I hope that airframe that had that problem is pride of place in the office somewhere. I hope you didn't put it in a skip. I hope it's
So
on a wall or
actually,
something.
that design aircraft was designed to land on its nose and crumple, which it did admirably. So the front arms bent on it, and the nose broke. The actual airframe is fine; it could fly, no problem. But we wouldn't fly it. So yeah, I do have a museum of disasters, and that's in there.
Well, perfect. That's perfect. That's exactly the sort of thing I was hoping to hear. No, that's fantastic. No,
Formula One.
I've had 33 minutes of your time. This is crazy, and this has taken a second.
Yeah,
So
always fun to talk.
looking ahead, then, what would you want Philip to change on your on the cubes to suit you, to suit you and other drone delivery people? What can you make better?
We're very happy with it. Reduce the price, obviously. I'm
Oh
sure
yeah,
everyone says that.
obviously, yeah.
So like we're very happy with it. I mean, he's already working on this. He needs to make sure that there's nothing that would hamper us using that in the United States, obviously, and he's doing a great job at that. So
Yeah,
like, there's
that's
nothing.
already done. Yeah.
I have no requests. Like, he always produces product on time. We've never had an issue with his product. It's always been reliable for us. It's easy to use, easy to embed. Yeah, there's nothing. It's a great product. Like, for everyone, for beginners building their first drone, right up to us, like a gigantic industrial drone company. We're happy with it, and there's plenty others I know that are just as happy.
So then, based on your experience, what advice would you offer to other companies then considering using the cube?
Um, Great question. I mean, there's various different cubes, right? We probably made a mistake at the start with the model that we used. There wasn't enough processor available. Like, we underestimated how much processor we were using in certain conditions, right? And it cost us a couple of aircraft on our test site as well, where like we just had tight loops and we were doing too much processing, and we killed it ourselves. So like, I would say, know what your onboard software is doing, know what your control loops look like, and what processor you're using, and just make sure you pick the right product for your particular software stack. And yeah, like in very early days, we didn't have the right cube, and we just moved to the orange, and we're happy. And like, stability is more important than functionality in this game, right? So if it's working for you, no matter how great, cool new stuff Philip comes out with, if you've got
Stick with it.
20,000
Yeah.
hours on it, don't change anything. So we don't change things lightly. And if we do change, it takes us a year to change them. Like, we put new props on our aircraft recently. It took us over a year to go through full testing to be able to introduce those props into production.
So I suppose that really speaks to, test it and then test it again, and oh, by the way, you need to test it some more. Whatever the thing is, and the whole thing,
Yep.
it might
Yeah,
take a
yeah.
little bit longer. But I'm going inside. Look, I've had a load of your time, and I didn't mean to. So I'm going to say thank you very much. I'm very pleased that you're happy with the cube and what it's doing for you, and thank you for your
Yeah.
time. And I look forward to following with great interest what occurs over there, and maybe even later in the year I'll get over to Ireland, hop on a ferry, and
Yeah,
have a
to
look.
everyone is invited. All your listeners, competitors, everybody is invited.
That's very good of you, Bobby. Thank
Uh,
you very much. We'll speak to you again.
See you soon.